Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Catalytic hydrogenation, H2PT, proceeds via SYN addition. Both hydrogen atoms are delivered to the same face of the double bond simultaneously. Moving on to the next step. The alkene is E or Z2,3-Dideutero-2-butene, i.e. CH3, C is equal to C, D, CH3. Each carbon of the double bond bears a methyl group and a deuterium. This makes both alkene carbons identical in substitution. Moving on to the next step. From the drawing, the CH3CH group and CH3 group are on opposite sides or same side of the double bond, with D groups placed accordingly. The key point is that both sp2 carbons bear the same two groups, methyl and deuterium, making this a symmetrically substituted alkene. Actually rereading, left carbon has CH3CH ethylic, but it's just CH3 attached, and D, right, has CH3 and D. So the two carbons of the double bond are C3 bearing CH3CH and D, C2 bearing CH3 and D. Wait, this may be 3-methyl-2-deuterio. Let's treat it as the alkene is such that hydrogenation produces two new stereocenters. And for the final step, H2PT delivers two H atoms from the same face. If the alkene is E configured, the two identical substituents on opposite sides, SYN addition gives the RS is equal to meso compound predominantly and the RRSS pair depending on which face is attacked. For a symmetrically substituted E alkene like E-CH3 D, C is equal to C, D, CH3 SYN addition from one face gives 2R, 3R, and from the other face gives 2S, 3S. These are enantiomers, forming a racemic mixture. For Z alkene, SYN addition gives the meso compound. The structure shown has CH3CH on one side and CH3 on the same side, both on top, with D on both carbons on the bottom. This corresponds to the Z configuration. But the image shows CH3, CH on upper left and CH3 on upper right, D on lower left and D on lower right, suggesting Z-like arrangement where similar groups are CIs. However, looking again, CH3, CH is on left top, D on left bottom, CH3 on right top, D on right bottom. This is E configuration. The two methyl-bearing groups are trans if we consider CH3CH D priority. For the E alkene with SYN H2 addition, attack from top face gives one enantiomer, attack from bottom face gives the other enantiomer with equal probability on an achiral catalyst. This produces equal amounts of R, R and S products is equal to a racemic mixture. B diastereomers, the two products formed are enantiomers, not diastereomers of each other, they are mirror images. C meso would result from Z alkene SYN addition, not E. D constitutional isomers, impossible since same connectivity results. Therefore, the correct answer is A. Therefore, the correct answer is option A.